Hi everyone, this is Dr. Jacobs. Today, instead of having a Zoom call, I decided to go ahead and film a video for you all that you can watch through Perusal to earn your attendance point for the day. Make sure that you have this complete before Wednesday, 9 a.m. on January 28th, 2026. Let's see if it'll let me do the slideshow. Perfect. All right, so we left off talking about measurement, remembering that a measure is a tool that we use to turn information into numbers, while measurement is the process of turning information into numbers. So whenever we have a measure and we measure anything, there's going to be some error associated with it. We already spoke about reliability, that it's important that our measures reliably or consistently measure whatever it is that we're trying to measure. And it's also very important that the tools that we're using to measure something actually do what they say they're going to do. So even if we have a perfectly reliable measure, even if we have a perfectly valid measure, it doesn't matter because there's always going to be error in anything that we do. Okay, so when we look at this formula, it says that the obtained score equals our true score plus error. This can be a little tricky, so let's break it down a little bit. So your obtained score, sometimes it's called the observed score, it means the same thing, is basically what it is that you get when you measure something. So if we took an exam over chapter 1, your obtained score would be the score that I give you on that exam. But we all know that sometimes our scores don't show what we know. Sometimes it shows more than what we actually know, and sometimes it doesn't show enough of what we know. So if I had a magical machine and I could just find what the perfect, what your exact statistics knowledge is, that would be our true score here. So in every obtained score, in every score that we get when we measure something, there is theoretically our true score plus our error. We have several different sources of error that can go into this obtained score. So let's talk about those a little bit. One is measurement error. So we cannot make 100% accurate measures. We can try to do our best. We can try to minimize bias. We can try writing awesome questions, but just because we simply measure the item, there's going to be some error in our scores that are associated with that. And I bet you've seen this. Sometimes teachers, and I'm guilty of this too, will write questions and we think they're great, but they actually aren't asking or you're not interpreting them in the same way as the teacher. So that could be measurement error. You've probably also had teachers, and I'm also guilty of this as well, where they marked the wrong answer as correct. And so those are sources of measurement error as well. Another source of error that we find is sampling error. Sampling error is the error that is introduced into our scores because we took a sample of participants rather than using the entire population. So there's some error in the scores that we obtain just because we didn't test everyone. And then our third one is random error. Random error is unpredictable. This could be because someone came and took their test hungover. It could be because people didn't sleep last night. It could be that you misread the question. It could be because the font is in red instead of black. They actually did a study on that, an experimental design where they randomly assigned participants to be in the condition where their test was in all red font, and then the control condition was all the font in black. What do you think they found? In that study, they found that students who took the test in the red ink did substantially or significantly worse on the test than people in black ink. So if things just as simple as the color of the ink on a test can influence, there's so many random errors. Are you hungry? Is it cold? Is it too hot? There's so many things, and we can't control for these random errors because we don't know exactly what causes them. So I'd like to use a test score example of obtained score equals true score plus error. Let's pretend you got a 99% on your last exam and your best friend got a 98%. You actually can't say that you did better or that you know more than your best friend. Because sometimes when we take tests, I always tell my students always guess. Never leave any item blank on a test because that will just hurt you. The worst thing that can happen when you guess an answer on a test, at least in my class, in most classes, is that you accidentally guess right and your score goes up. So let's pretend that if we had that magic machine to find out how much you knew and you actually knew 96% worth of the information. but you got lucky and guessed right on three of the questions. Now, however, let's pretend that your best friend forever actually had a true score of 100. That actually reflects what they know, but they either, let's say, error, maybe they accidentally filled in the wrong circle, thinking it was for a different question, or maybe they skipped one on accident, or they just didn't pay attention when they were reading. So, like, these are the things. So, just because we have a obtained score of 99 or obtained score of 98, there's not a big enough difference there that we're able to tell if they're who did better. And in fact, a lot of times students will ask me, okay, so how do we find out what that true score is? And actually, we can't. I know in some of the harder sciences, there are ways to try to figure out how much error is there. But within the social and behavioral sciences, we don't know. And this actually underlies why we need to do statistics at all. So if we are trying to see if there are if there is a significant difference between two groups, we need to make sure that those groups are far enough apart that those differences didn't just happen because of error or because of chance. And so that becomes really important, although it's really high level type of formula because a lot of times students aren't introduced to this until they start learning about intelligence testing or higher level stats classes. It's actually really important to know right away because this shows why we even need statistics to begin with. So, there are different variables in research design that you need to be able to know and identify so that we can make progress within statistics. For example, the independent variable, which is symbolized by IV, capital IV, you're going to want to put that on your symbol sheet. So if you need to pause me here, go ahead and pause me, write this down in your notes, and then go ahead and write it on your symbol sheet, and then unpause me and continue. So our independent variable, or our IV, is our grouping variable. Most of you probably heard a definition of this saying that this is a thing that the researcher manipulates. This is not actually always true. Because, yes, in an experimental design, we can manipulate which groups or what people get to go to what conditions. And that's an experimental design. However, a lot of research is conducted with something called a quasi experimental design. This is where we use naturally occurring groups and we don't randomly assign participants to conditions. With that type of design, we can't determine cause and effect, but there are still independent variables. So, if I wanted to examine if the number of hours that you listen to music, if there is a significant difference in people who listen to no music in their happiness levels as opposed to people who listen to 10 hours of music a week, our independent variable would be how much music they're listening to, right? So either they're in the group that listens to no music or in the group that listens to 10 hours of music. We can randomly assign participants to be in those conditions, no problem. However, if we wanted to do a study on who gets more sleep, 2-year olds or 21-year olds, we cannot randomly assign participants to be 2 or 21 years old. It's just impossible. So, in that case, we would just see if there's a significant differences between the groups. That's not causation, that's not checking for impact. That's just seeing is there a significant difference between these groups. So, in that case, our independent variable is the age, right? So, either you belong to the 2-year old age group or the 21-year-old age group. Another symbol that's related to our independent variables or IVs is the lowercase italicized k, and this is the levels of the independent variable. In other words, how many groups are we comparing? So, in our last example of comparing who gets more sleep, 2-year olds or 21-year olds, we would say that lowercase italicized k equals 2 because there's two groups. Either you belong to the 2-year-old group or you belong to the 21-year-old group. This will become important later on because eventually we can have more than one independent variable. But this for now is just talking about the number of groups within one independent variable. So you're going to want to take that lowercase italicized k and you're going to want to pause this video and go put that on your symbol sheet real quick. And then you're going to want to come back to me. All right, now that you have written both of these symbols onto your symbol sheet, I'll give another definition of lowercase italicized k. So either you can say it's the levels of independent variable, the number of groups. Sometimes people will refer to this as the number of conditions of your independent variable. So, for example, if I was doing a study to find out if I could randomly assign participants to third graders, let's use third graders to either one group not have any additional reading outside of reading class each day for a week, or we could have another group that has 30 minutes extra reading every day out loud outside of class in a week. And then we could have another condition where we have participants read silently 30 minutes in addition to their reading class each week. In that situation, we have three different groups, right? We have the no extra reading, the 30 minutes reading out loud, and the 30 minutes reading silently condition. In that situation, we have three groups, so we have three levels to our independent variable, which is reading condition. Or we could say that we have three conditions within that study. So now that we move on to dependent variable, our symbol for dependent variable is capital D, capital V. And you're going to want to go ahead and write that onto your symbol sheet as well. So our dependent variable, this is what you measure in your study. So if we're going back to the last example that we had where we have third graders, we randomly assign them to no extra reading outside of reading class, 30 minutes of reading out loud, it, in addition to what they do in reading class, or reading 30 minutes silently in addition to what they're doing in reading class. Our dependent variable in that might be how many words per minute third graders can read, or reading comprehension levels. So our dependent variable is whatever we're measuring. So if I wanted to see if people who read the chapter one reading learned more than people who did not complete the reading, I might measure some sort of quiz over chapter one, and that would be my dependent variable. The reading condition, reading it or not reading it, would be our independent variable, while a quiz over chapter one would be our dependent variable because that would be what we're measuring in the study. So go ahead and write that on your symbol sheet. Go ahead and pause me and then come back. All right, now that we know about both independent variables and dependent variables, we can move on to learning about something called confounding variables. So, confounding variables are any variable that can influence our dependent variable other than our independent variable. So, for example, if I was trying to examine if there's significant differences between students who take my statistics class in person versus my students who take my statistics course online, I am not going to be able to randomly assign who goes to which condition, right? So, one problem with that is that we don't know if both classes have the same level of IQ, right? We also don't know if the classes have the same amount of school readiness or quality note taking skills. Like all of those other things might influence how well people do in the class, other than whether or not they've taken the class in person or online. Whenever we're designing a study, we want to be able to minimize as many confounding variables as possible. This will allow us to make better conclusions with whatever we find with what we're studying. So, there are several basic types of research design that we're going to learn about in this chapter, and we're actually going to use these across the entire semester, especially when we get back to the inferential statistics, because the type of research design that you use influences what type of statistical analysis you'll be able to do. So, it's really important that you're able to identify these basic types of research design now so that we get that practiced and understood. That way, it's easier for us to determine what statistical analysis we're going to use later on for different research designs or different research questions. So, the first one that we're going to learn about is the between groups design. Sometimes you'll hear this referred to as between subjects design. Unfortunately, statisticians have a lot of different names for the same things. For this class, we'll use between groups design because that is the one that is most popular and that I've heard the most frequent. So when we have between group design, we have different participants in each level of the independent variable. You'll notice I put K here to represent levels of independent variables. This basically means that we have different participants in each of the groups that we're comparing. So for the example that I said, if I wanted to examine if people who read chapter one knew significantly more about chapter one than people who did not read it, I might randomly assign half of the class to read the chapter, half of the class not to read the chapter, and then we'd compare the differences between those two groups. Notice that we don't have all of the same participants in each level. We have different participants. We have half the class in one, half in the other, and that's what makes that a between groups design. Within group design, however, is when we have the same participants in each level of the independent variable. What do you think of an example of that might be? Go ahead and pause me and think about it and then hit play again. If you said something like a pre-test, post-test design, you are absolutely correct. So when we took our pre-test at the beginning of this year, we I got that from each of you. Now, when we go into the post test later, I will also collect all that information from each of you as well. What I'll do then is compare those two scores to see if there's a significant difference that you know significantly more at the end of the class than before you took it. As a teacher, that's how I help guide how I teach, making sure that my students are learning what they're supposed to learn. Because if students don't know significantly more at the end of the semester, then I haven't done my job. We also have something called match group design. This is where we measure all the participants on some potential confounding variable and then try to make it so that participants in each level independent variable have about the same amount of it. This one's a really tricky design to do, and we will go over in detail how to do this. Last basic type of research design that we have is a bivariate design. This is where we test the participants on two variables. In this situation, we don't have like multiple groups. This would be if I wanted to see if there's a significant relationship between how much sugar you consume and how tired you feel. I would test all of you on how much sugar you've consumed today. And then I would also test all of you on how tired you feel. And I would go and look and see if there's a relationship between those things. Okay, so I told you we'd go back through a match subjects design. This one's really, really tricky. I've never had to do this in real life. So we're going to kind of do an example so that we can go through it together. So if I was doing match subject design, let's say that I wanted to do some sort of workout to see if it decreased body fat or increased muscle mass. I might want my groups to be about equally distributed in this for what I'm doing. So, step one, I might use the DEXA scan to obtain the starting body fat percentage for all the participants in the study. So DEXA scans are actually something they can do in the Student Rec Center. They check body fat percentage, muscle mass, bone density, water, and it's kind of like a big fancy X-ray that gets all of these different composite scores for your body. And it's actually a pretty cool thing because checking your bone density is really important, especially if you have an eating disorder or if you're in late adulthood or if you are an athlete who has stopped menstruating because you exercise so much. DEXA scans can make you aware of how much bone density you have, which can decrease in all of those three situations. So let's go ahead and use this DEXA scan. Step two, we'd put participants in order from highest to lowest body fat percentage. So we'd literally put them in order. Step three, we'd take the two participants with the highest body fat percentage and randomly assign one of the participants to one of the conditions, let's say traditional weight training, and then the other one would go to the CrossFit. So we'd randomly assign one participant to one of the conditions and then place the other one in the opposite condition. Step four, we'd repeat this process until all participants had been assigned either to the traditional weight training or CrossFit condition. So, what this would look like is say, like, we're trying to see if people in traditional weight training or CrossFit gain more muscle mass within the first month of these types of training. So, something that could influence your dependent variable might be what they start out with their body fat percentage. And so we might want to go, okay, so let's do a DEXA scan on everyone. Let's put all the participants from the highest body fat percentage to the lowest. Then the first two participants will randomly assign one to be in CrossFit. The other one goes straight to traditional weight training. Then participants 3 and 4 will do the same thing, randomly assign one of them to the traditional weight training, and then we'll put the other one in the other condition. 5, 6, participants 7 to 8, participants 9 and 10 all the way through the process till everybody's been randomly assigned to each condition. Like I said, this is something that people use. They also have a more sophisticated version of this called propensity score matching. That is way above my pay grade, but it kind of deals with this similar type of design, except for they use it over across multiple variables just than one. So let's practice with our basic research design basics. And I kind of already foreshadowed this. Let's try it anyway. So if we wanted to see if reading an introductory statistics chapter helps students learn, I might randomly assign half the students in this class to read the chapter and the other half of the students in this class not to read the chapter. Lucky! Then I could compare how well the two groups did over a test or the material in the chapter. All right, so questions for this example. What is our dependent variable? And I'll go back to it so we can reread it. What is our dependent variable? Pause me, say it out loud, and then restart. If you said the test over the chapter material is our dependent variable, you are correct. So remember that dV is our symbol for dependent variable. So our statistics test score would be our dV. Then what is our IV? Okay, so we have to remember first when you read this question that IV means independent variable. So let's go back. What is our independent variable in this example? Go ahead and pause me like I'm Dora the Explorer. Say it out loud and then go ahead and push play again. If you said whether you're in the reading condition or not reading condition is our independent variable, you are correct. So our IV for this one is our reading condition, whether or not the participants had to read the chapter. All right, now that we've learned more about our dependent variable and our independent variable, how many levels are there to the independent variable? Go ahead and pause me, say it out loud, and then check the answer. If you said 2, you are correct. So now that we know more about basic research design, which one of the basic research designs would this be? And we can go back to the question or to the prompt. What type of basic research design would this be? Pause me, say it out loud, and then push play to find the answer. If you said this was a between groups design, you're correct. So that's all we have for today. Thank you all for being patient with the weather and helping us move along in our schedule so we don't get too far behind. We will have a data collection activity when we get back to class. Hopefully the weather will be better on Friday. If you have any questions, feel free to bring them to class on Wednesday. You can also type them into the perusal to be able to find out or so that I can see that you have questions. So stay warm, stay safe, and I'll see you.